So welcome to Microprocessor Lab. So in this session, we are going to learn how to write an assembly language program to perform the division of a two sign numbers using 8086. The mnemonics used to perform the division of a two sign number is IDIV, register bar memory. The two type of division that can be performed in 8086 are: one is a divide a word by a byte, which is nothing but a 16 by 8 bit assigned division, and divide a double word by a word, which is a 32 by 16 bit assigned division. So in case of a 16 by 8 bit division, for the sign numbers, we know the numerator a dividend is in AX, the divisor is a byte in the register or data from the, or you can take the data from the locations. So before the execution, so the AX will have a dividend. After the execution of this sign IDIV division, we are getting the quotient in AL, the remainder is in AH. So let us see IDIVBL. So we know that the data range here is in 8086 is from 00 to FF. In that 00 to FF, from 00 to 7F is the positive number and 80 to FF is the negative number. How we are telling this? First we have to check the MSB bit. We know that MSB bit is equal to 0, then the number is the positive number. If the MSB bit is equal to 1, the number is the negative number. So here the MSB bit is equal to 1. So the number is what? If the MSB bit is equal to 1, the number is the negative number. Let us take an example. So num1 and num2, here we have taken E3 and 15. So we have to check the MSB bit of this E3. So when you write the binary equivalent of this is nothing but 1 triple 1 0 0 0 double 1. And here the MSB bit is equal to 1. MSB bit is 1 is what? A negative number. How we are going to represent this negative number using the 2's complement. So what is the 2's complement of E3? We have to find it. So which is nothing but 1D. So this is the calculation. E3 we are going to divide by 15. We know MSB is 1. We have to represent using the 2's complement. So what is the 2's complement of this number is 1D. We know number is a negative, so it is minus 1D by 15. So using a long division method, we can able to get the value. Here the quotient is 1 because the number here is a negative. We are getting here minus 1. Again, the number here is what? A negative number. We have to represent using the 2's complement. So what is the 2's complement of this minus 1 is FF. How to calculate this remainder? So already we studied the formula. How to find the remainder? We have to take the dividend minus the divisor, which is here, the divisor here is 15, into the quotient. So here the dividend is what? Minus 1D minus, in the formula we have minus, the divisor is 15 into minus 1. If you do this calculation, we are getting your F8. So F8 is the remainder. So let us see the program. So we have to include the model. So it's assembler directive. We have to go with dot model small. Then we have to initialize the data. Here we have taken two numbers. One is what? Num1, num2. So both are defined as a byte. So it is db is what? Defined byte. E3 and 15. If you see the number here is E3. But the assembler will think E as the alphabet. To differentiate that, we have to insert 0 before this E. So 0 E3H. Number 2 is defined byte. The divisor you have taken here is 15H. We know here the result is what? A quotient and the remainder. So we are duplicating the result with a 2 copy. So result D defined by 2 duplicating with zeros. So after that we have to end the data segment. Then we have to go with the code segment. Assume CS colon code DS colon data. So we have to initialize the code segment and initialize the data segments. Once this is done, we have to take the address of the data. From this address will be assigned to data segment. So direct assignment is not possible. So what we have to do, with the help of AX, we have to do it. Then take the num1 assigned to AL. Here we have used CBW. CBW is nothing but convert a byte to a word. So what will happen here? A, a byte, 8 bit is converted to 16 bit. How we are going to convert this? For that we have a syntax CBW. So it will check the MSB of the number. If MSB is 1, 1 will be extended. If MSB is 0, then 0 will be extended so that we can able to convert a 8-bit number to a 16-bit numbers. So then, so that number will be in AX. The result of this, the result of this will be in AX. Now move BL comma num2. The second number is in BL. So we have to go with the syntax of what? A sign division. So we have to write IDIVBL. So what will happen? It will take the value of AX by the value of BL. We know we will be getting the quotient and the remainder. The quotient is in AL and the remainder is in AH. So directly we have to transfer that to result and result plus 1. Afterwards, we have to end the program by writing move AH, 4CH in 21H. So this is nothing but end the program using the DOS service. End the code segment and end of the main program. After typing the program, we have to go with what? A MASM, a file name .asm semicolon. Then we have to go with link a file name .obj semicolon. Once this is done, after assembling, after linking, we have to go with debug, okay, which is nothing but we are going to execute the program by typing debug a file name .exe. So U is nothing but the unassembling. We can able to get the code view of the written program. So this is the mnemonics and these are the instruction code and this is your code segment and this is the offset. See, after typing this, after typing U, we have to execute the program by typing G is equal to, we have to type G is equal to 00, the starting and the ending address. So 00 and 0018. This is the end of int 21H. So we can able to see the list of registers present in 8086. We can able to verify that what is the code segment here. The code segment is 076B and your data segment is 076A. After typing this G, the next step, we are going to display the result by typing D data segment colon 00. So we know the first number we have taken is what? E3. We know MSB bit is equal to 1. Okay, we have to find the 2's complement. The 2's complement of that number is what? 1D. So it is minus 1D by 15. So we are getting the answer. So what we got there? Answer is minus 1. Minus 1 2's complement is FF. So we got some reminder. That reminder is what? F8. So this is FF and F8. So these are the quotients and the remainder. Now let us see how to do this 32 by 16-bit division. So here, what is the difference when compared to the previous program? Here we are going to define a word. So we are going to perform what? A 32 by 16-bit division. So we have taken a 2 number which is nothing but a word FF73 and define word 0025. And we are getting the result. And here the result will be in dx as well as ax. So the dx will have a remainder, the ax will have the quotient. So what we are going to do, after taking this number, now move ax comma num1. So the num1 is transferred to ax. So what we are going to do, CWD, which is nothing but convert a word to a double word. So already a word is what? A 16-bit. That 16-bit we are going to convert to 32-bit. When you're doing, when you're going to do this conversion, the final answer will be in dx as well as ax. So now after that we have to write move bx comma num2, which is your num2. This number we have to transfer to bx. Then use the syntax for sign division, IDIV bx. The result will be in ax and dx. So what are the numbers we have taken? FF73. This FF73 is what? We have to check the MSB. How? For FF73, you're going to write the binary equivalent. You will be getting 1, 1, 1, 4 ones, again 4 ones. Then we will get 0, 1, 1, 1, then 0, 0, 1143. If you check the MSB bit, and here the MSB bit is what? 1. So the number is a negative number. If the number is a negative number, we have to find the 2's complement. The 2's complement of FF73 is nothing but 8D. Okay, it's nothing but what? Minus 8D. So the divisor is here 0025. The divisor is what? 0025. The dividend is minus 8D. So we have minus 8D, capital D, okay, by the divisor is 25. So if you do this calculation, we will be getting the answer. So minus 80 by 25. If you do this, we are getting your minus 3. Using the long division method, if you try to do this, we are getting your minus 3. So once again, this minus 3 is what? A negative number. Minus 3 is what? A negative number. So how are you going to represent this negative number? For that, we have to use the 2's complement. So the 2's complement of the 2's complement of 2's complement of this minus 3 is nothing but FFFD. FFD. So if you see in the location, so we know LSB of the data will go, then followed by MSB. What is the LSB here? FD. So this is the quotient, you are getting FD, followed by FF. So how to calculate this remainder? So what we have to do, we have to use the formula. So what is the formula? First we have to write the dividend. Okay, there is a formula, dividend minus, we have to take a divisor. Okay, this we have to multiply with the quotient. So this is to calculate, this is to find the remainder part. So let us see the calculation here. So now what is the dividend we got? Minus 8. This is minus 8D. Okay, minus of. Okay, the divisor we got here is 25. The divisor is 25. You're going to multiply with minus 3. You're going to multiply with what? Minus 3. So this is nothing but what? Minus 8D. Okay, 8D. Minus of minus will be plus. So plus 6F. 6F. Okay, if you do this calculation using the calculator, we will be getting the answer FFE2. E2H is a hexadecimal number. So FFE2. How this data will be stored in the location? First LSB will be going, followed by the MSB. So what is the LSB here? E2FF. So thank you all.